We're going to now look at an example of trying to solve this system with three equations with three variables. So what we have to do is look at our system and figure out, okay, which variable seems like it's going to be the easiest to eliminate. So what I usually look at is finding a variable with a coefficient of 1. So like the x has a 1, the z has a 1. I just find it's easiest. Sometimes it creates the least amount of mistakes when we're multiplying. And I'm actually going to eliminate the x just because it's positive. So that means that I need to pick two equations. It really doesn't matter which two you use, but two equations to eliminate this x. So that means we need to make two equations have the same but opposite coefficient. So if I'm looking at this middle equation, I see that it has 2x minus 5y plus 4z equals 13. So what I'm going to do is multiply this top equation by negative 2. So we would get negative 2x plus 2y minus 3z. Nope. How about we multiply all those things by 2? So negative 2x minus 4y plus 6z equals positive 6. And then we're going to add it to that middle equation since it has the same but opposite coefficient, a positive and a negative. And we will add them together. So we get our x's to go away. We get negative 9y. 6 plus 4 is 10z. And 6 and 13 equals 19. Okay, so we've got one equation here with two variables, but we got to get another one. So now we're going to go back up to our system of equations, and we can use like this same equation if we want. We can use a different one, but we just have to use two of the three to eliminate the x again. So what I'm going to do is I'm going to use this last equation and the first one again. So if this is 5x, I'm going to multiply this guy by negative 5. So then that will give us negative 5x minus 10y plus 15z equals 15. And we're going to add it to the bottom one. 5x plus 4y minus z equals 5. Add those guys up. X's should go away. So we have to make sure we don't like eliminate an x the first time and then a y the second time. Both times you're doing this double elimination, you're getting rid of the same variables so that when we have our two new equations, we have the same variables in them. So like our two equations are going to be left with y and z. So negative 6y plus 14z equals 20. Okay, so these are the two equations that we are going to use to set up like a regular system of equations like you've done since Algebra 1. Like I said, it's just getting to this point that is new. So we'll set negative 9y plus 10z equal to 19 and negative 6y plus 14z equals 20. So here we have to do a regular solving a system of equations. So you could solve it technically for substitution, but really the best way to do it, I think, is elimination. So either looking at the y's or the z's, doesn't really matter, but I'm thinking I'm going to eliminate the y. So we're going to make both of these 18. We're going to make the top one positive 18 by multiplying by negative 2. Make the bottom one negative 18 by multiplying by 3. So we get 18y minus 20z equals negative 38. and negative 18y. 14 times 3, can't do mental math right now, 42. Equals 60. And then add those guys up. So we get 22z equals 22, so we've got z equals 1. Okay, so obviously getting to that first variable is the most complicated step. So once you get that first variable, now you've got to plug it into one of those gray equations in that system of equations with two variables. So we're going to plug it in. Plug in z that we just found. So negative 9y plus 10z equals, and what did we just say z was? 1 equals 19. So we get negative 9y equals 9. So y will be negative 1. And then we've got to plug in one more time to get that last variable. So we will plug in both z and y then to get our x. So we can plug that into one of our original systems of equations in the original problem with 3 equations. So I'm just going to pick the first one there, x plus 2y minus 3z. So x is what we are trying to find, plus 2 times y we said is negative 1, minus 3 times z we said is positive 1 equals negative 3. So let's see, negative 2 and negative 3 is minus or negative 5, and then we'll add that 5 over, and x equals 2. So when we get our solution, we like to write it as an ordered triple and goes in order, so x, y, z. So 2, negative 1, 1. All right, I'm going to try to do the second one a little quicker since you kind of know the steps. And you guys can just kind of follow along. You can even try it on your own if you want. So 3x plus 2y plus 4z equals 11. 2x minus y plus 3z equals 4. 5x minus 3y plus 5z equals negative 1. I'm going to get rid of the y's. So let's do these guys. I'll multiply this by negative 3. So negative 6x. Okay. Negative 6x plus 3y minus 9z equals negative 12. The quickest thing here, or the most important thing here, guys, is just making sure you take your time. There's so many steps involved that if you rush through it and you mess up, it's hard. It takes a while sometimes to go back and figure out where we went wrong. So negative 6 and 5 gives us negative 1. Y's will cancel. Negative 9 plus 5 is minus or negative 4z equals negative 13. All right, and then we got to do the y's again. So I'll use this equation this time and multiply this guy by 2. So let's see, that's going to give us 4x minus 2y plus 6z equals to 8. And we're going to add that to 3x plus 2y plus 4z equals 11. So 7x plus 10z equals 19. So we've got our 2 equations with 2 variables. This is where we now set them up and just do a normal system of equation elimination with 2 variables. So I'm just going to multiply this guy by 7. And that'll give us negative 7x minus 28z, 13 minus 7, 91. Add them up. X's will disappear. And then we've got negative 28. So we're done with this guy. Negative 28 plus 10, negative 18. And then negative 91 and 19. 72. And then divide 72 by 18. So we get z to be positive 4. So then we've got to plug that guy back into one of those gray equations with just 2 variables. So let's do negative 1x minus 4 times 4 equals negative 13. So negative 1x minus 16 equals negative 13. Add that 16 over and get 3. So x will be negative 3. And then we've got to plug in one last time to get that third variable. So any one of the original 3 equations, let's just do the first one. 3x, so 3 times negative 3, plus 2y is what we're finding, plus 4 times 4 equals 11. So we've got 3 times negative 3, so negative 9 plus 16 gives us 7. Subtract that 7 over, we get 2y equals 4. And then divide by 4. So y equals 2. We've got all 3 of our variables. Let's write our answer as an ordered triple. X, Y, Z, negative 3, 2, 4. And just like anything else, guys, all we did here is solve a system of equations. We solved equations for given variables. So you can always plug those values back in and check to make sure that you got the right solution. But really, we are getting a system of 2 equations with 2 variables by using those original equations and doing double elimination. And then once you get those 2 equations, it's just like you've done since algebra 1. Use elimination to get one variable and go from there. Getting that first variable is the hardest piece.